very hearty good evening to all the participants for this weekend talk. Center of Excellence in Safety Engineering and Analytics, IIT Kharagpur welcomes all the participants to the weekend talk in Safety Engineering, Management and Analytics. This program is conducted under Azadi Ka Amrit Mahotsav, commemorating 75 years of India's independence. We start the program with this wonderful shloka, Asatoma Sadgamaya, Tamasoma Jyotirgamaya, Mrityorma Amritam Gamaya, which inspires us to lead from ignorance to the truth, from darkness to light, and from death to immortality. Today we are bidding adieu to 2021, and CoE-SEA family wishes our dear participants a very, very safe and prosperous new year in advance. There's an announcement that there are online short-term certificate courses on PTD, Prevention Through Design, to prevent accidents and injuries at workplace proactively. The course details are mentioned as shown in the slide. So all are requested to register for the courses as per the given details. We welcome all the dignitaries to the virtual dais. Today we have with us an expert speaker, Mr. V. Narasimhan. After 36 years of service, Mr. V. Narasimhan, a chemical engineer by profession.
I'm a chemical engineer and safety consultant.
Yes, sir. And he's a senior executive officer from Coromandel International Limited, a Chennai fertilizer factory. He specializes in the production of ammonia, fertilizer, and management of utility plants. And he was in charge of ammonia terminal for 10 years, which is the biggest in Asia. He underwent training in process safety management for 5 years and was the internal auditor of the company for PSMS. After retirement, he joined as a process safety consultant with Ram Safety Consultants, Chennai. He has done about 100 project reports in safety audits, risk management, risk analysis, mechanical safety audits, fire safety audits, etc. He also did the South India's major airports risk assessment for BPCL, HPCL, and Indian Oil Aviation retail outlets. And from 2016, he started his company and his associates and was a chief safety consultant and has done numerous safety audits. He attended 6 international conferences for OHS Safety International, Jordan Chemical Engineers International Conference, European Chemical Process Safety Management Systems. And ladies and gentlemen, the list is endless. And today we have a very interesting topic, process safety management systems for chemical industries. And Mr. Narasimhan has started his own company, Narasimhan Safety Consultancy, in April 2021. And several memberships bestowed honors on him, such as American Institute of Chemical Engineers, American Process Safety Management, Global Risk Professionals Association, Institution of Safety Engineers in the UK, and ESH Association in the US, senior member in the Institution of Safety Engineers, India. Now I request our chairman, CoE-SEA, Professor Maiti, to formally welcome our expert speaker. Thank you, sir.
Thank you, Mom. Thank you, Mr. Narasimhan, for
accepting
our request and taking a lot of travels to prepare as well as with us. And you know that we have a procedure and the system, and we have gone through our procedures in the process, and we are really thankful to you. And your topic is extremely important for all of us. Process safety management systems for chemical industries. And even that, with these few words, I also want to inform you that CoE-SEA is always looking for speakers like you with industry experience as well as that knowledge on the subject matters. So we are thankful. So Mr. Narasimhan, please start your presentation.
So my talk about process safety management system started in 2018. I'm process safety management. This is the 15th process safety management webinar. Totally, I have talked about process safety and behavior-based safety, risk management, so on. It is my 31st webinar. including the international conferences. So what I'm going to talk about. There is a proverb in Julius Caesar. The Mort Cantoni talked about the murder of Julius Caesar. My Roman countrymen, lend me your ears when I go to the pulpit talk about Jesus. The same way I am a preacher of process safety management. Can just please technocrats of IIT and friends, please hear me for about 40 minutes about the feisty process safety management elements in a good way. That's how I'm going to start. Because of the so many critical situations, the first industrial revolution took place. Next, please. Next. Talk about next, please. Next. The objective is in 1912, the first industrial revolution took place, and a lot of accidents did happen. People do not know what to do. So the faulty machines and lot of gases emanating from chimneys. Due to that, lot of people died were not noticed. And then the World War came in 1914 and 1918. Because of it, nothing could be done due to the prevent accidents, and there immediately the second.
Hello, sir. Swing.
Sir,
Yes, are you able to hear?
sir, I think he has lost his connection.
Oh. Sir, you are muted, sir. You are muted, sir.
Mr. Narasimhan, you are muted.
No, he is unmuted, but we are not able to hear. No, sir, we are not able to hear you. No, sir, no, sir.
Participant, we are sorry. Problem with connection of Mr. Narasimhan. We'll see for 1.5 minutes.
Please unmute yourself, sir. Yes,
Unmuted.
yes, we can hear you. Yes, sir. Yes, sir.
People were educated, wanted to do something costly to ward off injury and death due to accident. Then came the Clean Air Act Amendment, came in year 1990, not 70, 1990, to avoid pollution and other steps. Mute பண்ணு. Then came, then the whole incident cast 2,000 death, killed 23 people, and 3 mile disaster formed OSHA. A lot of and lot of made 90 and 19 Washington conceived wanted to do something the people and in the world. At last, they made it as compulsory and mandatory for all industries within the US, in Europe, and Britain, and the Gulf countries. In the process safety management system, under which 14 elements initially came, and then 17 elements. How the Bhopal incident came into being. The US Union Carbide people first established. I'm telling about the incidents happened, what has happened that led to process safety management system. So the Union Carbide started the 2 plants, one at Bhopal, another at Jammu Kashmir. So they manufacturing pesticide, Savion. So they usually from Jammu and Kashmir, they usually bring the MIC, methyl isocyanide liquid, by tankers till 1976. Then they wanted to make it in the Gopal plant itself. There were a lot of teething troubles when they started the MIC. So a lot of people, 24 people died initially. Then one chemical engineer died of 30% burns. So these are all happened within 3 years of operation. The union people suspected something, and they went to the government of India and launched a complaint, but nothing was visible. Son, I am coming to the main portion of the disaster. So there were 3 tanks, vessel 609, vessel 611, and 605. In that, what has happened? That they used to fill up MIC up to 30 tons. So 2 tanks were emptied out. So they give nitrogen pressure to come to get the liquid out. So 1 tank V609 was having 42 tons of liquid. They could not pump the liquid because of so many. Because they have not given nitrogen pressure. Nitrogen blanket is the must for any tank using MIC. So they have not done it. They have not serviced the pressure relief valve. What has happened? On the December 8, 1984, December 2. So they wanted to pump the liquid nitrogen, but they could not do it. So what has happened? In the meantime, it is the part of the management, say some rogue element has done the bloody thing. Because usually it is underground tanks. Usually they will have hydrogen points around the plant. So one
Yeah, Mr. Narasimhan, unmute and speak. Unmute and speak. We are able to see you, but not able to hear. We are not able to hear you. Swin,
Yes, sir. Sir?
will it happen or
Sir, he's not picking up the call, sir.
today when you tried all these things are
During the trial, he had this issue, but when he connected with his hotspot, there was no issue. But I don't know what happened today. Today he said he's been connecting from his hotspot, so this issue must not actually occur. But today, I don't know, sir. The trial was fine. During the trial session, there was no much issue.
now it is becoming unstable. Swin, please inform him that we'll arrange one more time for him. Then we'll see for alternative now.
Okay, sir. Okay.
You unmute him. So, gentlemen, sorry for the disturbance because Mr. Narasimha is not able to connect. I request one of the great speaker, Professor Maiti, who very recently gave a keynote speech in the international conference held at International Conference on Maintenance and Asset Management held at Australia. So I request Professor Maiti to please share his talk with us. Sorry that we are asking you in the last moment. Professor Maiti, is it okay?
Yeah, no problem. Only thing is that I think that okay, just Swin inform him. And
yes,
another thing is that
we'll
the presentation. Yes. So let me share the presentation from my side. Acha, Sobik, my share content is not active.
Yes, sir. I am giving.
Swin, please inform Professor Narasimhan.
Sir, he is online.
Yes, sir. Now you can share.
It's coming?
Yes, sir. Yes, sir. It is coming.
So, okay. So, I think as the situation basically not supporting today that about this one. So again, we are extremely sorry that there's some kind of network issue. We all are struggling today, and definitely the lecture will be arranging once more. Today, I will just discuss you something like safety analytics. Basically, this is very hot topic nowadays. Everybody is talking about analytics. In the first day lecture, I have given a little of safety analytics, but today I will give a little more. So please, I hope that it will be definitely useful to all of you. As the time is, it's a different time now. So what I will do, I'll give you the very subjective part of it. So, but safety analytics is a very, very quantitative one. And here I want to also inform that we are bringing one NPTL course. NPTL means basically online open course on safety and risk analytics, which will be running from I think January 18 next year, means to 2020 2022. So now let me tell about that introduction. Basically, this introduction I always like to give, but the primary reason is safety. When you are talking about that safety analytics, basically the two kind of safety issues comes to our mind. One is process safety, another one is occupational or safety, including workplace safety. Now the case here, Piper Alpha case, it's a process safety. So in process safety, what actually happens? Lot of process parameters are measured and monitored, and you get lot of data. And from there,
now can you hear me? Now it is. Can you hear me?
Mr.
Yes,
Narasimhan,
we
we'll
are
do one
able
thing.
to hear
Your
you.
full talk, we'll make one more session because
we will, yeah.
We'll schedule your talk in one more session. I will inform you. Now let Mr. Professor Maiti complete his talk.
Okay. Thank you.
So, and you know that in Piper Alpha case, the explosion killed 168 people, and after that, there are a lot of inquiry, and finally, that the Sir Brian Appleton, after Piper Alpha, said that safety is not an intellectual exercise to keep us at work; it's a matter of life and death. The next sentence is very important for all of us. It is the sum of our contribution to safety management that determines whether the people we work with live or die. So, okay, with this message, I want to set the tone of today's lecture. If you just see the industrial revolution over the years, today is basically fourth industrial revolution or industry 4.0. That is basically the today's context, very important. And industry 5.0 is also very much present today. Now, but if we look back all the industries, primarily high risk industries also, you will find out that they are established long back. Some are some are even 100 years old. So then, and with the industry 4.0 technologies, now what we are doing, we are redesigning the system to cope up with the today's requirement. So then the Einstein quote is very, very valid here at this point, that what a great Albert Einstein says, the world we have created today as a result of our thinking thus far has problems which cannot be solved by thinking the way we thought when we created them. So that means today, if you think in the same manner that, okay, safety and health issues will be solved the way we used to solve, that is not the case. Today, in the changed world, there are a lot of changes, not only from the technology front, from the societal requirement front, from the regulation and other established codes and acts from point of view. Everywhere there is a change, and now you have to cope up with all those changes with the demand that increased demand for safety. You need new thought. You have to think differently, because that is the reason we IIT Kharagpur is working in the area of safety analytics. Now, in nutshell, what are the key issues that you basically discuss in safety in the safety engineering and management domain? So that will be the first thing you have to understand, that what are the different domains that can be included under the safety engineering and management paradigm. So in the right hand side, we have enlisted many of them. Not necessarily that these are basically the, I can say that these are the totality or the exhaustive list, but many of them we have highlighted or enlisted here. For example, under key vertical, we have enlisted safety analytics, industrial safety, mine safety, transportation safety, oil, gas, and chemical safety, in the same manner up to public safety, including MSME safety. These are basically, apart from the first one, these are basically the application area. Now, you all know that when we talk of safety, that the first and foremost thing that should come in everybody's mind is prevention through design. So the prevention through design, then hazard identification, risk assessment, like this, there are many broad thematic areas. So why I am saying all those things? Because today, if you want to think of the total safety management, then you have to understand, or at least group wise, there will be efficient and adequate resource, human resource, as well as other kind of efforts to tackle the present day safety requirement. So prevention through design and redesign is comparatively new, whereas hazard identification and risk assessment is very traditional. But at the same time, now cyber physical systems are very prominent. So you cannot avoid this. So cyber physical system safety and security. Now, what is happening here? The security issue, some of the earlier safety issues were majorly dominating. Now, safety as well as security is coming because of the use of the, I can say, the technologies like the sensors and your IT-based systems like this. So data hacking and data breaching, so many things are coming into picture. So you have to augment your domain now from the safety to security level. So safety, occupational security, particularly from the industrial industrial application point of view. So our first message, that basically the center of excellence in safety engineering analytics, we are trying to tell the stakeholders, you have to augment your domain. So augmenting domain, it should not be that abruptly it should not happen. It should happen with logical ways and innovative ways. And that is basically we are saying in search of new thoughts. You have to augment your safety domain, safety management domain, safety engineering domain, and safety practice domain from the concept, then design, then your operation maintenance to even to up to disposal in such a manner that you will not miss any of the important things, and your entropy risk as well as total risk will be at a very minimum level. So what you are getting from this slide, basically what I'm saying, that you all the thematic areas, whatever may be your application domain, maybe it's a steel industry, or it may be a transportation industry, or it may be manufacturing or automobile, that you have to see that whether the thematic areas what we have enlisted in the right hand side, that is captured or not. Now, if I say augmenting domain, another important part is that you cannot forget or ignore the industry 4.0 and 5.0 technologies and techniques. That is at the that third layer. You see that virtual reality, augmented reality, artificial intelligence, machine learning, Internet of Things, then human technology, data analytics, decision model, simulation, epidemiology. So these are the important technology and techniques domain. What also the safety discipline is basically as taking into their consideration. So now the issue is that is it possible that only industry will be able to do it or only industry academia will be able to do it? It is not possible by any one of us. It requires close interconnection between industry and academia, and that is the purpose of the center like ours, and we are basically helping industry in this particular manner. Now you can understand that then where is the safety analytics? Yes, I'm coming to this. Then that means the first challenge or the what way you have to think, you revisit your system that whether the issues are all the safety and health related issues are identified or not, you are doing something on it or not. That is basically issues, key verticals, thematic areas. Second is basically that if you want to do safety analytics, you have to have data. Data is a big challenge. Now, we don't know what is safety data, how to collect safety data, how to store safety data, how to prepare data for analysis. So, and then what are the different kinds of model that can be used. So in this manner, you can find out it's a big challenge, and it's a novice state now. And it is not that in India only, in worldwide, people are now struggling for good safety data. So here you have to innovate. You have to innovate because unless you innovate, you will not able to collect the data that is required for safety analytics to be done. So now if I can define safety analytics, I will tell you that safety analytics is nothing but data driven safety engineering and safety management. Data driven, and whatever you say, it should be data driven. There is data, there is analysis, and the findings are after analysis, the findings are considered, and then the decisions are taken. One such approach for data capturing the right kind of data is basically micro hazard mapping and management. What Professor Krishna has been promoting, I think, since last, I think, 10, 15 years, that when he was in Tata Steel and much before, from that time, basically you have to understand the hazards in a right manner. Means we should not have, if I ask what is hazard, I am telling you, if you ask 10 people, then eight people will be saying maybe the fire is the hazard. But he's not understanding that the fire is required for the production point of view or function system functionalities point of view, or it is the outcome because of some wrong handling or some kind of bad events this fire has occurred. If it is a coke oven plant where the blast furnace fire is by design, then it is hazard. But if you are talking about you are driving a car, at the same time what happened because of maybe some reason that there is a fire in the car, then this is not a hazard. This is outcome or accident. So that is the point where basically you also require to understand hazard fully. So I'll request later on maybe Professor Krishna to and one day what is micro hazard mapping and management, how to identify hazard using the hazard triangle principle. He will be explaining. But I'll not explain all details. Then the totality I'll not be able to complete here. Only thing you have to understand that when you are talking about hazard triangle, then there are three elements. One is hazardous element. Second one is incident causing mechanism. Third one is target, the threat and target. That to be understood. If we understand hazard, yes, incident causing mechanisms, threats and targets, then you are in a position to find out the path. What is the accident path? This gives a big relief to the practitioners because if you know paths, potential incident or accident paths, then much of the interventions are known. But what happened actually traditionally, what is happening, we are following on hazards, but partly basically the portion of the hazard, not the three elements of hazard, only the portion of the hazards. And as a result, hazard removal is not complete one, because if I cannot measure what I want to improve, your knowledge will be meager and unsatisfactory kind. So first and foremost thing is you have to measure, then only you will be able to improve. Now, if I consider a half of the hazard triangle, then obviously your whatever interventions or efforts we put, that will be half. So it will not be full, it will not give us the full benefits. But if you understand hazard triangle, then the incident path you will be able to create. And if you are able to create incident path, then there are two important issues, that how to prevent the accident to happen and how to reduce the consequence even if an accident happen. They are the biggest part of it, the most important part of any safety, for any safety engineers or safety managers, in what are the risk control system. Now, I have analyzed a lot of data. Professor Krishna also, we have analyzed. We found out that most of the times the data what we got, these are not giving us full picture of the hazard triangle and the incident path. What is the incident path? Hazard to because of certain mechanisms, accident, and then finally threat. This path, all those elements are not available in the data set. If we do not create the path, we will not be able to understand what could be the the intervention failure. So that is biggest challenge for all of us. And IIT Kharagpur Center of Excellence Safety is working on it. If you all go through the HSE data, HSE Health and Safety Executive, actually with a leading and lagging indicator on paper is the write-up is there. Another one is what are the risk control systems. They have identified 9 risk control systems for process industries. This includes inspection and maintenance, staff competence and covering, and like this, up to your communication, permit to work, something like this. These are the things I have explained you a little earlier, probably. But my question here is that data is an issue, and you don't have data for an incident that what RCS has failed. Even if some cases we found the RCS that whether it is a problem of design, it is a design oriented accident or design failed accident, or it is inspection related failure or maintenance related failure, but we did not get data that what are the weakness parameters of the risk control system and effectiveness parameters of the risk control system, and those data are not monitored. So ultimately what is happening, we don't have good amount of data. But then people will say, okay, we are managing, but what is the need of good data? Why will go for so much of effort in understanding the concept, then putting a lot of effort in collecting data, documenting data, then storing and analyzing. I'm telling you that if you do this, then it is very much cost effective and it's a business. So data itself is a business. So that competing with analytics, if you want to win, if you want to win over hazards, win over risk, then data analytics, safety analytics is to be there. So in safety analytics domain, data is a major challenge. In our week, that open lecture, I think the 2 weeks lecture will be there only on creation of data. If you find time and if you have enrolled, fine. Otherwise, if you do not have enrolled yet, then if there is opportunity, you may enroll, or otherwise, you can wait for next year. Now, issue is that safety analytics. What we are saying that if you want to have safety analytics in place for your organization, this slide gives you a complete picture of it. I said that first and foremost, we require to understand hazard. Professor Krishna will always say that if you know hazard in detail, you know the accident. So 50% work is done. I also say the same thing, that first you have to understand the hazard triangle. If you understand as a triangle, your accident path or incident path, how many incident paths possible, that also you will know. If you know the incident paths, this is nothing but that from the Swiss cheese model, from hazard to harm, the alignment is path is nothing but the alignment. That alignment actually when lot of layer of RCS fails, then only the accident takes place. That will be known to you. And if I know for my system, even if a small plant or even for a equipment or a workplace, if I know that how many ways the accident can happen, then you see that you know that what are the interventions to be put into. And but please keep in mind that it is not. It is true that most of us, particularly in the industry, you all know all those things. What is missing based on our experience is that the systematic approach of doing it and some kind of procedures is missing. Like operating procedure, if it is not available, workers are not able to do the good work safely. Similarly, if you want to prevent accident, this data-driven management, if you want to adopt, the procedure is needed. You see the middle part of this slide where we are talking about RCAs. At the same time, we are talking about lagging indicators and leading indicators. Let me tell you that what is leading and what is lagging indicators. Leading indicators means now you have to think RCAs just like another equipment or a machine. Suppose a machine is what is the function of a machine, purpose of the machine? The machine definitely takes certain inputs and it converts into value-added outputs. So if you see that, take the blast furnace case, blast furnace takes lot of inputs and finally molten metal is the output. If you consider SMA, steel melting shop, molten metal is the input, but ultimately the billets and other kind of or steel slabs, these are basically the some cast product. These kind of things will be okay. That thing will be output. I think SMS is steel melting shop. No, I am talking about cast. Suppose when the final product is coming that from molten metal to the different kinds of slabs. So that means if you think that your process maybe a reactor or the machine, maybe a crane, or as I told you that another process, coke oven. So if when they take inputs and provides value-added outputs, and you have parameters you are monitoring, what is going to happen now, their quality will be hampered. So you always take sample and then finally you readjust the process parameters or you train the people. That way you all are doing. So this is the way you have to think the risk control system. Inspection and maintenance is one of the risk control system, and it is a process kind of thing. So it just like a reactor, the way it works, inspection and maintenance should work in the similar manner. If you want to develop your knowledge base in this manner, you will know what are the inputs that inspection and maintenance program require, so that the value-added output means that there will not be any incident or any undesired events which are caused by inspection and maintenance. That will be the desired safety outcome. So your input, and now you also require to know what are the parameters or the criteria that, or the activities or actions you have to do, so that inspection and maintenance as a RCS like a machine will perform. So this is the crux of the matter, the thinking, because as I'm telling you that you have to think differently now. This is the era of things like your staff competency. So that means we are saying, okay, we have recruited the staff who are very good, they are capable enough, but we are not forgetting at the same time one thing, or we may not be forgetting, but suppose the training is required, periodic training is required. Okay, some training we are giving. Is the training effective? If training is effective, then why that kind of human errors are actually happening? So that means we are taking this risk control system, which basically capability building, or competency building of the staff or the workers or all the employees point of view, we are not taking it like a machine, taking it like a process, like a machine. We are taking it as a one-time venture. And we are not thinking that what could be the inputs and what could be the controlling parameters so that the desired safety outcomes will come for this particular risk control system. So if you do not think in this manner, you are much 100 miles away from leading and leading indicators. Leading indicators means what inputs, what you are providing, what activities you are doing, what actions proactively you are taking so that the desired safety outcome will be delivered by the risk control system. So that since we have to understand the leading indicators. For example, I suppose one indicators I am telling you inspection point of view. You know that in a particular operation or a particular workplace, you have a schedule. Suppose you require to complete 10 inspection or over a particular period. If you do not do this, then this is the activity what you should have done, you have not done it. So here percentage of inspection completed on schedule, that could be the leading indicators. So that is what we are trying to tell you, that you have, suppose communication is just another one. In order to make communication effective, what are you doing? You to understand that. So now suppose there is a procedure change and you have not communicated to the maintenance crew, next maintenance crew, and lot of accidents, high level accidents that have happened in the past, there is a problem of communication because there is a change, either some kind of plan change or some kind of procedural change, and that takes place, but the next shift crew, they were not informed. So that means percentage. Then what could be the leading indicator? The percentage communication, percentage of changes in operating procedure or permit to work, whatever may be, the changes that have taken place properly communicated well in advance or not. These are basically leading indicators. For every plant, for every system, you must understand how many risk control systems are in practice. There could be 9, there could be many more. If you are not happy with the classification here, 9 classification, you create your own. But you have to understand that in order to make the risk control system effective, what are the inputs? What are the activities and actions that has to be taken care of? And are we doing that? If we are not doing, there is the failure, and that leads to failure of the RCS. That means what will happen? If inspection and maintenance are not done correctly, the lagging indicators will be basically the desired safety outcome will not come. You may say one of that is basically weakness indicators from the risk control system point of view. Now, there are a lot of many examples can be given, but just for the time being, as I told you, that suppose if you analyze the incidents and if you find out how many are due to inspection failure, then that could be one of the lagging indicators for you, percentage kind of things. Now, now you think of a situation, even a small plant, there are many machines, subsystem, workplace, all those things. Even if you consider 9 risk control system, and for each risk control system, there will be a few number of leading and lagging indicators. Now, if you can understand and measure all those leading and lagging indicators as per feasibility, as per suitability, you see that enormous data will be created. Enormous amount of good data will be created. It is not costly because every time we are doing it, we may think that why should we do? We have to do because you are actually doing it. Only thing is that there is no systematic procedure to document it, to store it. And if we do like this, what will happen? You will be flooded with data, whether it is a process safety or workplace safety or your additional occupational safety, whatever you can say, that you will be having a huge amount of data. And lot many safety programs are basically made for this, like safety audit, like workplace inspection. I know some one industry, they are doing job cycle check, they are doing high risk control programs, so contractor safety audit. So many ways, and HIRA means that hazard risk assessment programs, HAZOP, you are doing every day. It's not that we are not doing, we are doing, but we are not understanding the path of accident and the utility of the all the efforts what we are putting, and the utility of the documentation of it. So you will find a lot of data. Once you have data, then the what D.W. Deming told about quality movement in the 20th century. You have seen lot of quality initiatives have taken across the world, and like Taguchi, like Deming, like Crosby, like Spiegelbaum, and Juran. So many gurus are there in the quality domain in the 20th century, and today's quality is enormously improved because of the movement. Some people from the academia, from the industry, they have taken the right kind of path, and they push all those things, and the quality movement has taken place. Environment movement also similarly started, but it is a very difficult one still going on. Why not there will be safety movement in the same manner? Who prevented us not to do this? It's basically mindset. It's a attitude problem, caring attitude. We don't have. We should have nationwide caring attitude, mindset that okay, even a 1% cut in the finger, it should pain. It should pain to us also, others also. If we think in this manner and capture data in the way we are basically telling, this is the one way of capturing data. There could be many other ways you can find out. Then I also say that, or we all can say that we believe in God, other must bring data. If you have data, your analytics started. So that is the birth of safety analytics, as I told. And in fact, Professor Krishna will agree with this. None of the concepts what I have given here is unknown to us. It is known to all the big industries also. But why then data is not coming in the same manner? It is not coming because of the problem with the with our attitude, with our negligent mindset, non-caring attitude. I request all of the audience, whoever here and others, let's have safety analytics movement in India, and let other world will know that this is what. Then the another, suppose okay, you understood all those things. The next challenge is, do you have effective framework to do this? Actually, this is basically safety enterprise. We don't have enterprise concept in the safety domain effectively understood, and the procedure or implemented. You require it. So here I have given a very simple structure, and that structure just to tell you that how industry and academia can come together and could have a national hub, and but maybe at IIT Kharagpur there could be a hub, the safety data hub, and where all the industry, the companies, they will get whatever information they want. Suppose they want to know working at height and a particular situation, what could be the solution? Simply they have to just search that particular cloud, and they will get the answer. So that kind of initiative IIT Kharagpur has been taken, and I hope that over the time, with the help of all of you, we'll have this kind of this kind of infrastructure, like NEOS what they are doing, like NASA what they are doing, like our ISRO, that the level they are operating, that level in the safety point of view from it is possible. Then comes that actually this is the biggest challenge for practitioners. Practitioners has no time, and we also believe so. because their purpose is safety is definitely very extremely important, but the production is equally important. So if they capture data, gather data, analyze data, it is impossible for them. So here the challenge is, okay, I have so much of data. One very prominent industry that management asked me, we have so much of data, but we don't know how to analyze it, and tell me what is the analysis. So there, academia, university, research labs, the scientists, analysts, they have big role. So industry wants to know from us how to capture data, how to store data, then they will do all those things. Once data is captured, stored, then industry again asks us these many questions. What happened? Why happened? What will happen, when and why? What actions to be taken? Is my company is basically aware of analytics? Is my company is analytics driven company from the safety management point of view? All those things basically we have taken from the data analytics side. You just look back few years when in 2005 or 7, that time Davenport said that competing with analytics, then business analytics, the way it basically simply changed the business concept. So and ultimately today the delta concept. Delta means DELTTA. D means data, E means enterprise, L means leadership, T means technology, T means target, A means analytics. From the business analytics point of view, organizations are delta based. Delta means that is enterprise. Enterprise is there, already created. Data, but organization is adaptive to analytics. Why not that the same principle will be applied to safety domain? This is possible. And as a result, what we are saying, those who have gone through or have come across the analytics, data analytics, you all know these words: descriptive analytics, diagnostic analytics, predictive analytics, prescriptive analytics, cognitive analytics. When you have data and you are in search of what happened, just you want to know the status, that basically comes under descriptive analytics. But if you want to dig down little more, that why it has happened, suppose Chernobyl accident or your Bhopal gas accident. If you want to know why it has happened, you are basically dissecting the whole issue. You are diagnosing the issue. That is diagnostic analytics. Then, as we don't want any undesired incident to happen, so what you will basically say that, okay, let me see that if I don't do anything, if I maintain the status quo, what is going to happen tomorrow? And obviously, when it is where it is happening or why it will happen, this kind of question for future, if you want to understand, that is called foresight. So foresight is predictive analytics. Then you want to know, okay, there could be n number of actions can be taken. What is the best action, or what is the best combination of actions? Then that is prescriptive analytics. And last is cognitive analytics. Means everybody will ask you, okay, you tell me, you are saying this happened because of this. Where is the data? You tell me, where is the analysis? And the data, information, and the actions all will basically from the top to bottom of the organization, they will automatically getting disseminated. That means the way a human brain works, suppose you get a hit somewhere, then what will happen? Suppose sometimes there's a trip. So then automatically your nervous system will give signal to the brain, oh, something what happened, and then action. So this kind of organization is possible, and it is happening in the business analytics domain. Then it is not unknown, it is known. So we have to do it. So if we can do that sense, then cognitive analytics. Here the cognition is the innovation. You have to innovate that way. So now from the modeling and inside their drawn point of view, there should be tie-up between industry and academia. Industry will find out whenever they find capture data, they immediately it will come to the maybe the academia cloud are there, and the academia will analyze and give you all the answers immediately. That kind of collaborative learning is required in this domain. IIT Kharagpur in a very big way working on this analytics, collaborative learning, all those things in different ways. Our group is working on safety, some group is working on quality, some other group is working on supply chain, some group is working on even the engineering analytics point of view. So then now the another one is performance monitoring. This is another important part of it. That performance monitoring, if you see, so I will just what I will do, I will stop by another 5 minutes because almost already it is 9. The traditional performance monitoring of okay, what accident taken, how many accident taken place, or how many unsafe action conditions are there, that whatever benefits you can get, you already got it. Now you have to find out incident path or accident path-wise monitoring. Okay, or potential incident path monitoring, potential accident path monitoring. It has not happened, not occurred, but it could have happened. So this is one approach we have already given to you. So then how to use Industry 4.0 technologies? So there are so many technologies I have enlisted, human sensing technologies to cognitive ergonomics, surveillance through video, safety as a service concept, smart devices, VR, AR in safety training. So the list could be more, so you can do it. And decision models, actually probably people even today, people think that safety decision, what is there? There is none. But yes, if it is a high risk industry, even a small deviation can cause havoc, then decision making is a key issue there. So you have to, there are models, there are many recent developments, and there are breakthrough developments in the decision modeling point of view. And in fact, in January, one lecture we have arranged on decision analytics. So I request all of you to attend the lecture. So with this brief discussion, I conclude that safety analytics is an emerging area. It is proactive and promotes prevention through design. Being data-driven, it provides quantitative decision support system. It enables the use of advanced technologies, tools, and techniques. It is based on Delta principles. Safety risk and related decision will be governed by safety analytics, and it is coming in a big way. So let us hope that we all will be geared towards safety and risk analytics, and will be doing fantastic work. And here are some acknowledgement. Thank you for your patient sharing, because it is all of a sudden I have done it. So maybe I could do little justice, but I don't know how much you have got it.
Thank you, sir, for this wonderful lecture. We have some questions in the chat box, so I am taking some. Can near-miss events also be described with the concept of safety ontology?
Yes. So see that near-miss event, basically that could have happened. It has not happened. That's why potential part is coming. It's yes.
Yes, sir. Yes, sir. Now the next question is, how can we describe cascading incident, that is one incident that leads to another incident, with the help of safety ontology?
Yes, you can augment this one at the page end. What actually we have given? We have said accident, and then immediately we have gone for threat, and then we have gone for target. Now the cascading means one incident leading to the series of incidents. So that incident box can be further developed to account the cascading effect.
Yes, sir. Yes, sir. The next question is, preventive risk control system usually act as a barrier for the initiating mechanism part of the accident path. Can it act like a barrier for the pivotal event also?
See, pivotal event is a part of the incident path. What is pivotal event? When something goes wrong, immediately the accident will not take place or incident will not take place. For example, in my safety engineering class, I used to give a pressure system example where maybe the pressure gauge is malfunctioned, and as a result, what happened? The overpressure condition arises. It will not lead to, but immediately it will not lead to the accident. So that initiating mechanism here is basically that maybe the pump overrun means what basically maybe that basically supplying gas or air to the pressure vessel. So if the pump overrun takes place, then what will happen? The pressure in the vessel will increase. So initiating event maybe pump overrun. If you consider, then immediately accident will not take place. Then the pressure gauge is there, that alarm is there. So pressure gauge actually will capture this, then alarm will sound, operator will see, then there will be relief valve will release the pressure. All those subsequent events, what actually, these are all pivotal events. So the question is basically prevention. Risk control system means not only the initiating event, it is the entire causing mechanism starting from initiating event and pivotal event. So all those, even if you can prevent the last pivotal event before accident, then accident can be stopped.
Yes, sir. Yes, sir. Thank you, sir. The last question is, are there any proactive measurements available for understanding the safety management system of an organization?
Repeat.
Are there any proactive measurement available for understanding the safety management system of an organization?
That is leading indicators. Answer is leading indicators. So if you understand risk control system, and then if you can create a leading indicator for every risk control system, and using the leading indicators, if you develop your safety management programs and activities and actions and efforts, that is basically the answer to this question.
Yes, sir. Yes, sir. Thank you, sir, for your explanation. Now I would like to invite Professor Krishna to formally provide vote of thanks to our expert speaker. Over to you, sir.
Yeah. First of all, Professor Maiti, thank you very much. With little notice, I have pulled you. But let me ask the audience, who can speak on safety analytics better than Professor Maiti in this world? Whether from the academician side or practitioner side, if anybody want invite to speak on safety analytics, it is only Professor Maiti. He can speak 6 months to the students on the safety analytics. He can do 3 years project on safety analytics for the government and the industries. I can speak 15 minutes in the keynote address on this safety analytics. Because your DNA is converted into safety analytics, totally.
Thank you so much.
And let me tell you, this Center of Excellence in Safety Engineering and Analytics, why IIT Kharagpur started analytics, Professor Maiti has explained you very well. The world do not understand safety analytics. Everybody feels they are doing analytics, but actually they are not doing analytics. Unless you do prediction from the data, it is not called analytics. You should be able to do prediction from the data. So if you want to do prediction, you require huge data. That's what Professor Maiti explained, leading, lagging indicators, risk control systems, all these things. Thank you very much, Professor Maiti. And this weekend sessions, we have started on 4th of June 21, where Professor Maiti was there. He had given his brief note on these things. The first session we started in the first week of June. Now we have completed around 31 sessions by this time. The CoE-SEA has tried to give knowledge to the industries and the academicians and the students through this forum. I get huge number of feedbacks. People keep asking why not we have full short-term courses. I told you now CoE-SEA is getting matured. It is now having resources to conduct all these things. We have so probably the short-term courses, which is one of the important thing for the industries. For the industry people will be starting if the present situation just eases out, we are prepared to do offline courses. If it doesn't ease out, probably we may try on the online courses also. And I'm very sorry we have to discontinue the speech of Mr. Narasimhan. He's a very experienced man, very knowledgeable man. But because of the technology, we had to discontinue. But next time we'll see. Next time when we call him, this is also one of the good experience to us. Probably for some places where the connectivity problems are there, we'll take the recorded lectures so that it will not be interrupted. And the whole team of CoE-SEA, who had been engaged in making this very successful. I'm thankful to all of this team. After all, Professor Maiti is the chairman of CoE-SEA. He is the leader of this. So under his leadership, the whole team is working. I thank for the whole team, including industry people like Mom Mitra, and many people are helping us. After all, CoE-SEA is US. So I thank all the people who are helping in this. And I'm very happy. A lot of likes I see in the YouTube uploaded lectures. Please take please enjoy and take the benefit of the YouTube uploaded lectures and NPTEL. What Professor Maiti said, that's also you can get. You'll get degree also from there. You'll get certificate also from there. Thank you very much. And we'll promise you when we reach 50 sessions, we'll call the most probably one of the best CEO who had shown passionate, his total passion towards safety. We'll search a CEO and we'll bring director also again to give their views and to take feedback from all of you. Some of you will ask feedback. That 50th session we'll have very wonderful session which will be in the year 1922. Thank you, Professor Maiti, again. Mom, thank you very much to you and your team. And participants, all the participants, thank you very much. And Mr. Narasimhan, even you spoke few minutes, you have given a lot of insights about process. Thank you very much. Thank you very much. Okay. We'll see tomorrow again. Not tomorrow, sorry, next Friday again. Thank you.
Yeah, thank you.
Thank you, sir.
Thank you.
Thank you, sir. Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir.
Thank you very much, sir.
Thank you.